प्यारे बच्चों, कैसे हैं आप। आज बच्चों हम सेकंड ऑर्डर डेरिवेटिव के बारे में डिस्कस करेंगे। फर्स्ट ऑफ ऑल, व्हाट इज द सेकंड ऑर्डर डेरिवेटिव? लेट अस डिस्कस द डेफिनेशन ऑफ द फर्स्ट ऑर्डर डेरिवेटिव एंड सेकंड ऑर्डर डेरिवेटिव बिफोर discussing the exercises, before discussing the applications of the second order derivative. So if y is equal to fx be a function, then dy upon dx is equal to d upon dx of f of x is equal to f dash x is called the first order derivative of the function y is equal to fx. Is called the first order derivative of the function y is equal to fx. So after finding the first derivative, you can find the second derivative also. So what is the second order derivative of y or fx? And because dy upon dx is equal to f dash x, again differentiating both sides with respect to x, both sides with respect to x beget d upon dx of dy upon dx, that is equal to d upon dx of f dash x. This implies it is denoted by d2y upon dx square. This is the second order derivative of y, d2y upon dx square, and that is equal to f double dash x. तो बच्चों, ये है परिभाषा सेकंड ऑर्डर डेरिवेटिव की, और सेकंड ऑर्डर डेरिवेटिव इस प्रकार से निकाला जाता है। सेकंड ऑर्डर निकालने के लिए आपको फर्स्ट ऑर्डर तो निकालना ही होगा। dy बटे dx निकालेंगे और उसके बाद दोबारा dy बटे dx का डेरिवेटिव लेंगे, तो आप सेकंड ऑर्डर डेरिवेटिव निकाल लेंगे। वो होता है, डिनोटेड बाय होता है d2y अपॉन dx स्क्वायर, एंड f dash x becomes f double dash x, and it is called the second order derivative of fx, and d2y upon dx square is called the second order derivative of y. Now let us discuss the application of the second order derivative. NCERT exercise 5.7, question number 1. Question number 1, find the second order derivative of x square plus 3x plus 2. This is the given functions, x square plus 3x plus 2. We have to find its second order derivative. So let it is equal to fx or y. Solution according to the question. The given function is f of x is equal to x square plus 3x plus 2. Differentiating both sides with respect to x. This is very, very important to write. With respect to which variable? differentiating both sides of equation 1 with respect to x, we get d upon dx of fx, that is equal to d upon dx of x square plus 3x plus 2. d upon dx of fx is denoted by f dash x, and derivative of x square is, applying the formula of derivative of x ki n into x ki power n minus 1, then it becomes 2 into x ki power 2 minus 1 plus 3 outside, and derivative of x dx upon dx is 1, and plus derivative of constant 2 is 0. You can also apply d upon dx to separate to each one, and it is also clear that you can also find the value directly. X square का derivative 2x, 3x का derivative 3, and constant 2 का derivative 0. F dash x becomes 2x plus 3. This is equation number 2. In order to find the second order derivative, you have to apply it. You have to use these steps. Equation बनाओ ताकि आप लिख सकें कि differentiating both sides with respect to x. Now, in order to find f double dash x, you have to again differentiating both sides with respect to x. Again, differentiating both sides of equation. Second, with respect to x, we get d upon dx of f dash x, that is equal to d upon dx of 2x plus 3. This implies f double dash x, derivative of f dash x becomes f double dash x, that is equal to derivative of 2x is 2, x का derivative 1, 2 is constant outside, and plus derivative of constant 3 is 0. Therefore, answer is f double dash x is equal to 2. This is the answer of this question, and this is the second order derivative of the given function x square plus 3x plus 2. That's all. Now question number 11. It is given that if y is equal to 5 into cos x minus 3 into sin x, then show that d2y upon dx square plus y is equal to 0. This is the question. And here, in order to prove this, in order to show this, you have to find the second order derivative of y. Hence, it is the question of the second order derivative. Solution. According to the question, y is equal to 5 into cos x minus 3 into sin x. That is equation number 1. Differentiating both sides with respect to x, we get dy upon dx is equal to d upon dx of 5 into cos x minus 3 into sin x. That is equal to derivative of y is dy upon dx with respect to x, 5 into cos x minus 3 into sin x. Applying the algebra of derivative, derivative of first fx minus gx is equal to derivative of fx minus derivative of gx. सेपरेट डेरिवेटिव इन दोनों. फिर 5 आउटसाइड एंड cos x का डेरिवेटिव माइनस sin x. -3 outside and derivative of sin x is cos x. It becomes d upon dx of 5 into cos x minus d upon dx of 3 into sin x. Applying the formula derivative of fx minus gx is equal to derivative of fx minus derivative of gx. Taking 5 outside, d upon dx of cos x minus taking 3 outside, derivative of sin x. Applying the formula of derivative of k into fx is equal to k outside and derivative of fx here and here also. And it becomes 5 into derivative of cos x is minus sin x minus 3 into derivative of sin x is cos x. And therefore we get dy upon dx is equal to minus 5 into sin x and minus 3 into cos x. That is the equation number 2. In order to find the second order derivative, you have to first find the first order derivative. Without finding the first order derivative, you cannot find the second order derivative. Because in this question we need d2y upon dx square. Therefore, first of all, you have to find dy upon dx. Then again differentiating equation number 2, you have to find the value of d2y upon dx square. Now, again differentiating both sides, equation number 2 with respect to x we get. Now again differentiating both sides of equation number 2 with respect to x, we get with respect to x, we get d upon dx of dy upon dx. That is equal to d upon dx of minus 5 into sin x minus 3 into cos x. This implies we get d2y upon dx square is equal to minus 5 outside, derivative of sin x is cos x, minus 5 into cos x, minus 3 outside and derivative of cos x is minus sin x, minus 3 into minus sin x, and it becomes d2y upon dx square is equal to minus 5 into cos x plus 3 into sin x. This is the second order derivative. If we take this to the left hand side, we get d2y upon dx square plus 5 into cos x minus 3 into sin x is equal to 0. Now from equation number 1, putting this value, this is the value of y. Hence this question becomes d2y upon dx square plus y is equal to 0. Hence the result, this was our requirement using equation 1. We get this, and this was our requirement. We have to show that d2y upon dx square plus y is equal to 0, and this is the result. Simply putting the value of 5 cos x minus 3 sin x is equal to y, we get this. This is the result. That's all. Question number 50 of exercise 5.7. Application of the second order derivative. If y is equal to 500 into e raised to power 7x plus 600 into e raised to power minus 7x, then show that second order derivative of y is equal to 49y. In order to prove this, you have to find the second order derivative of the equation number 1 of the given function. According to the question, y is equal to 500 into e raised to power 7x plus 600 into e raised to power minus 7x. This is the equation number 1. Differentiating both sides with respect to x, we get dy upon dx is equal to d upon dx of 500 into e raised to power 7x plus 600 into e raised to power minus 7x. That is equal to 500 outside and e raised to power 7x. Applying the formula of derivative of e raised to power fx. E raised to power fx, further derivative of fx. And e raised to power fx is e raised to power 7x, and further derivative of 7x is 7. And in this case, e raised to power minus 7x and further derivative of minus 7x is minus 7. Derivative of x is 1. And it becomes 500 into e raised to power 7x, further derivative of 7x, that is 7, plus 600 into e raised to power minus 7x and multiplied by the coefficient of x or further derivative of minus 7x, that is minus 7. And it becomes 7 multiplied by 500, 3500 e raised to power 3500 e raised to power 7x minus 4200 e raised to power minus 7x. This is the value of dy upon dx. This is just first order derivative. But in this question we need second order derivative. Now again differentiating both sides of equation number 2 with respect to x. Then we will find d2y upon dx square, and then by calculation we will get its value 49y. Now again differentiating both sides of equation number 2 with respect to x, we will get d2y upon dx square is equal to 3500 outside and again differentiating both sides of equation second with respect to x, we get d upon dx of dy upon dx, that is equal to d upon dx of 3500 e raised to power 7x minus 4200 e raised to power 7x, and derivative of right hand side becomes d2y upon dx square, that is equal to 3500 outside, derivative of e raised to power 7x is e raised to power 7x further derivative of 7x or multiplied by the coefficient of x. It becomes 3500 e raised to power 7x multiplied by 7 minus 4200 into e raised to power minus 7x multiplied by minus 7 or derivative of minus 7x, that is minus 7. फार्मूला लगा यहाँ पे e raised to power fx का derivative, that is equal to e की power fx further again derivative of fx. This is fx and it becomes multiplied by 7, 70, 700, 35 and 24 e raised to power 7x minus 700, 700, 14 and 29 and it become positive. Minus minus plus. E raised to power minus 7x. And taking 49 common from here, we get here y. After taking 49 common, we will get here 500 and 600. E raised to power 7x plus 600 into e raised to power minus 7x. Taking 49 common from here, and this is the value of y and 49y. Therefore, we proved that second order derivative of y is equal to 49y. That's all.